The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spent a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another Kilauea volcano update. Today is Thursday, March 10th, 2022, and you guys are seeing a thermal video of the last week on Kilauea here. That's been from images from the USGS HVO, Hawaiian Volcano Observatory, compiled by Dane DuPont and also by Bob Martin. Mahalo you guys. We're going to, as usual, talk about what's happening in Kilauea this week. We're going to look at some curiosities. We're going to look at the West Vent complex changing and the pattern of uplift at the crater floor for that, essentially. Look at some time lapses, media, and some of the lava viewing that's been submitted by some of our viewers today. So that's our menu today. It's our normal kind of a little bit maybe on a shorter side today if we can get through it a little bit quicker. But starting off here's what's been happening in Kilauea over the last week on the video. As we talk through this, feel free to submit questions. We'll chat. What am I trying to say here? Nothing very easily, apparently. But we'll be discussing questions live as we go along, and they'll be answering questions in the chat as you can, and we'll collect some to talk as we go along. Let them know if you have any issues with our audio or our video, and apologies for coming to you guys a little bit late today, having some technical issues with some of those devices not getting recognized, as is the case when we're doing this like low budget broadcasting as we are here. So mahalo you guys for all your support. If you haven't liked, shared, subscribed, please do that now. We'll see that off the top. And we'll jump into it here. This is a thermal image of the last week, as I said before, and we're looking from the west, so north would be off in that direction. This is our west vent complex. This is this area right in here, and it consists of this persistent pond that I've been calling the west vent pond, and all these series of cones that are putting out spatter and lava flows as well over here just to the right, and this image is just to the south. And this originally was a larger single cone, but we'll talk about how this has changed over the last month here today. So with that little orientation, you can see that we've had one big overflow at the start of the week that went into this northern area. This whole northern area here in the foreground, it looks like I mean, it is a massive area, but it's a little bit skewed, distorted by this camera view. Right, this whole area is probably the same as like that amount of area back there. This far side of the camera, it's just because of the angle of it. So this is the near vent area, and you can see it looping around here. And besides these overflows from this west pond vent area, the spatter coming up from these spatter cones, putting out small flows, you can see lava refilling this intermittent lava lake now, right? And as well as this other pit to the side, which you can see is clearly a separate feature with a division forming now. And in fact, if I can get this to respond to my thing, get this to zoom in here, you can see there's a division starting to form between this lowest most pond, and they called these cascading ponds last week. I like that. And an upper pond up here, this upper west vent pond that goes through this spillway channel, right? And even this spillway channel is starting to crust over a little bit as well, as we'll see here in this dark spot forming right across that gap there. And it's also visible in some of the other images we'll look at. So that's the overall big pattern. It's pretty similar to before. Ooze-up flows are on that perimeter of the crater itself. But it's notable that this darker area, I'm trying to outline it right in here, this darker area right there, it's that original crust core of that eruption that began in the end of 2020 and went through 2021. And this eruption, when it began in 2021, began with that smaller area of crust as well that got flooded over. But there's something extra buoyant about that crust that makes it float on this lava lake. So it's been uplifting as well. And the core of it seems to be fairly intact, but we're seeing ooze-up flows in this whole range between the crater wall and that inner perimeter, right? It's almost like a dartboard in a sense, where there's a whole outer ring here, right, between the inner ring and the outer crater wall right through there, where all the lava is able to come out the most easily, right? And not so much in the middle, although there's a couple of spots where you see the heat, and we've seen little flows from there as well. So that's the regular speed. I'm going to pause this now, and I'm going to drag it back and forth really fast, because what I hope you can see, and I'm going to have to zoom in a little more and point out right in here, right, this whole area is bulging upwards, and it's visible by the change in the cracks right around here, especially from this view. So if you look in that area, and let's see if I can grab this and finish. You can see it moving. It's maybe not as obvious how much it's bulging there. I'm going to zoom out. In any case, it's something I can see on my screen. If you're looking at a phone, it might be harder to tell. But this is just 1 week of time lapse right here, and the amount of bulging that we see and the movement of cracks. We see the cracks developing, changing all through here, right? We pointed out cracks last week on the southern margin over here. And so it seems like that's the edge of it, and it seems like it's basically pushing up and you're having ooze outs. And interestingly, marking this line of these cracks lines up exactly with where our west vent pond and west vent complex actually is, right? So as we move this around, see if I can back here, you can see that this whole bank is moving, but everything on its backside is stationary now. We'll maybe see that a little clearer in the next version of this time lapse here. But to start things off here, for you guys who are viewing in a national park, everything is still in the green. Air conditions are in the green. Viewing is still something you can check out from the Hawaii Volcanoes National Park webpage, as far as viewing areas and all of that, right? But as far as hazards, the main hazard is still the gas. It's still intermittent with a lava coming out, and we're still in the green for the most part here. So our VOG forecast here is what I'd call low to moderate levels of VOG, depending on where you are exactly. And when a VOG is coming out the most is when the lava is coming out the most, and it's blowing with strong winds right now, mostly to the southwest. But you can see that there are times when the wind swirls and it could reach these northern areas of the island. And not in huge concentrations, but possibly detectable if you're at risk or extra sensitive. That's our hazard impact right there. And we're going to jump in today in a little slightly different order. Our curiosity this week is going to be this image that was issued by the USGS last week, which we didn't really cover in an update last week because it was in between Dana and I's coordination there. But this is going back to the beginning of February. Essentially, it's February and the very beginning of March here. And you can see several things. One thing is at the very last frame here, you can see that this we have this one larger cone at the top right of the image and a couple of smaller ones here and here. If I reload it to go put it back to the beginning, get it to reload. That's it. And you can see that this larger single cone is not the main feature anymore. But what I urge you to look at is this front side right here. There's a big bunch of lava flows that keep swinging around and have actually buried most of this. So the actual ground level in the last image is somewhere around at least halfway up this cone, if not near the top of it. And so it is falling apart what's remaining above the lava level, but it's also getting buried by lava flow coming around the sides here as well. That's interesting, and that's the vent part of it. And we could also look at the pond a little bit as well, because this is something that... Is it going to stop cycling? Force it again. And just images or the formats are not quite friendly as it could be. So here is our west pond area. I formed that little archway. It seemed like it refilled, destroyed it. You see the camera moves a little bit, so the actual location of this pond and on the view is changing a little bit, right? You can imagine that this is something that the scientists are adjusting as needed, and is also susceptible to the wind and that kind of thing. So this is our curiosity. We'll look into this a little more, right? This main one big complex getting buried and then turning into 1, 2, 3, possibly 4 different little cones there. So what I'm going to do is we're going to pull back the entire eruption beginning from September 29th, and we're going to go through it really fast, all in 4 seconds, and then we'll have this thing loop around and we'll look at different aspects of this. So this is the first hour of eruption here, when lava was coming out of that middle of the crater floor before this lower west vent opened up, which is what we're going to look at next. It's all going to go really quick, and I'm going to zoom into different parts of it, so I'll just start looping it right now. And you can see that for the most part, we have a contraction of lava. You see the flashing of lava all around the perimeter. That's all those ooze-up flows circulating around. And you see this area in the middle where you don't really get as many of them. There's one that occurs in the middle partway through here. So that's the one pattern. Maybe you can see the bulging coming up right through here. You can see the cracks forming on the perimeters right through there. Perhaps you can also see the extent of this active intermittent lake here is shrinking more and more and more, and that's in fact why we're having this isolated little pit here on this far reach of it over here, right? So it looks like everything is moving. It is, because this whole crater is moving up, right? The whole crater floor is moving up, carrying all the features with it, and at the same time it's shrinking and bulging extra in the middle and oozing out the sides all through there. Okay, so back to our curiosity, if I come into this bottom right corner here, we can look at the evolution of the cone as well. So we can see that originally we had that west cone was actually attached to the wall of the crater here when this began. And as the lava level has gotten higher and higher, and this has been drifted and grown upwards, it's created a gap between that center of that lava fusion zone and the crater wall right here. And so now we have this little gap. And as a result, lava flows are able to swing around and flow into this area between the cone and the crater wall, as we pointed out with that new little vent that occurred here in the southern part last week. And that's part of what's burying this cone. So that's why I want to zoom in and show this extra close here today, so you really can see how this seemed like in the first few weeks, the lava was actually lifting the cinders and it was rising with it. And then later on, it seems the lava starts flooding around it and actually burying it and no longer lifting in the middle of it. And if I go back to this bulging phenomenon here in the middle, maybe you can see it coming up. Looks like it's bulging right through here, right in there. That bulging phenomenon there is essentially the difference between this middle part being able to rise buoyantly and this outer part not rising anymore, right? So we were kind of tracking that originally, like whether the whole crust was lifting together, and at that time, the most of the crust was this middle part, and so it was. And now the big obvious difference now is that we have that gap and it's not lifting together. The outside parts are not lifting, and so we have this division right through here where the lava wants to leak out. And not surprisingly, that's where our West Pond pit is. It's also where our West Pond complex is. But interestingly, that edge of that that plate is that same spot we've been watching in the east margin that's formed hornitos or spatter cones that are like hornitos. Also speculatedly along the edge of that hardened crust and the lava oozing out from below. So all liquid all the way below there, and those are the main features of this time-lapse curiosity. It's curiosity of the week here, but also this a time-lapse. Won't call it of the week, but helping us dig into that. So we have some media as well. We'll look at some of the media now. Here is USGS release of some of these cones. Here's one of them caught with a spatter burst. And the reason I want to make sure we note this is people were asking how tall are those things, and here's the answer. 19 meters, 60 feet is the tallest one of these spatter cones. Right? So there's one view of it. There's another view of it. You can see the lava's dribbling out the side with these slow-moving flows out the side of it as well. Similar caption on that one. And a third one here, showing more of that outer view. You can see dribble of slower moving lava down the side right there. They also mention other cones in this area are 15 meters and 9 meters. That is 50 feet and 30 feet. So if you're curious how tall those cones are, at least 1 week ago, they were 60 feet, 50 feet, and 30 feet. Right, and so 19 meters, 15 meters, and 9 meters. Guys, following metric. All right, so we'll pull out this V1 time-lapse from the last week, and we'll play that, and here's spatter cone number 1, number 2, and number 3. And I think this one on the top right, this is a large one. That's that tallest one right there, 60 feet one, right? And you can see is first of all, the frame moved right there. So I'll pause this and pull it back, right? So from earlier in the week, we have the West Pond Vent, lots of eruptions going on, but you can see that right on the 5th, that's coming up this following evening, the camera shifts downwards right there. So now we can see more of this lava lake draining feature phenomenon over here, and more of the top of this cone and features over here as well. Nice series of spatter. You can see these cones growing. It's hard to tell how far that is, but definitely a few meters, a few yards, you'd imagine, right? So I'd say that those estimates are on the lower end from a week ago. And maybe here at the very end, you can see, and I've been saying either 3 or 4 different cones, and it's kind of hard to tell, but I come here at towards the end, you know, there is the one. There's a second one here in a closer foreground. This is almost like a double. There's a second one right behind it there, and that would be the 4th one, right? So that's the view, and so we'll look in here at the current view, V1.
Well, those things, sorry to interrupt, but those things really remind me of the back of Fissure 8. That backside little cones that we see.
Yeah, good point. And I think that it's fairly similar in that sense, right? We're not getting that full first burst of lava that with the high fountains, but we're having like that later stage kind of cracking and stuff shooting up and oozing out. And Dane, maybe you can reset your camera for me. I think you're frozen on my display here. So yeah, let's see. I see a question about options for viewing, so we'll get to that with a comment that it's possibly not viewable from the volcano house area, volcano house side, and yeah, we'll discuss that here today as well. So that's coming up. Just want to finish here on this V1 for the last day, and just to note that little crusted over section right there, right? Almost like a small little tube it's going through right there, but as soon as lava level drops, it'll probably be unsupported, it'll probably collapse. And we've seen that be the case with the margins of this spillway channel over and over again. So it can split over and get much wider and collapse and get different shape like that as well. Okay, so moving on. We have some new thermal images released by the USGS. This one from March 2nd, so a little bit over a week ago. This is the larger caldera map, right? So for you guys who are wondering which of these places I'm talking about, we just mentioned the visitor center being over here. The Volcano House Hotel is not far, right over there. Uekahuna Overlook on this side, and Kanakakoi Overlook is on the south side. So most of the viewing we discuss, the best viewing is usually from over here, looking that way. So it's on this far side of the crusted over lava lake where all this is happening, and I'll scroll down here to get the zoomed in view. Here you can see the darker spots, one labeled the island here, that central island. You can see these eastern ooze-outs, we'll call them, right? That original darker colored core of the crust is something like this now, right? It's actually a smaller area, apparently, than the ooze-up area that surrounded everything all around, which is fascinating to me. Like how as a lake has risen and we've had our inverted ice cream cone, the crater collapsed in and it's flared outwards, right? So as the lava level fills it more and more, it spreads out more and more. And now it's spread out so much that there's as much area of the spread out as there was of that original deeper pit, a deeper plug. And as we pointed out last week, as a curiosity last week, this extra little southwest pond is visible on this little basin here, right? It's not the same kind of pond. This one over here is fed from below, from deep down. And then deep down, it comes out of a crack here, which spills over into a small little basin. It seems like it's slightly separate from this basin, so now it's forming a slight different puddle when it's oozing out there. And that's one of the things that you possibly can see when it's happening from that Kanekakoi area here, as well as these lava flows in the backside caught on this image. So viewing, here's a park map. We pointed out these areas, Uekahuna, right? I like the spot that's between Uekahuna Overlook and Kilauea Overlook by the old navigational beacon there. It's the kind of a rock area. Rocks are piled up in that area. You can you'll find it if you're looking, if you don't know what I'm talking about. And from there you can look down and you can see essentially this sector, this eastern sector, and not the most vigorous part of the eruption, but you can sometimes see lava flows dribbling and oozing out over there. And this area is one that lava's been visible from there sporadically for a while, and this whole path is paved the whole way here. It's only about 1/8 of a mile, so for some people that might not be able to make the entire 2-mile round trip, about a mile one way, a little more than 2 miles round trip hike from Crater Rim down to Kanekakoi, that's another option, right? You could get there a lot more easily. So that's the one viewpoint. Here's the other one. The third one is going to be this eastern side of the crater over here, from which lava has been reportedly been spotted. You can see the tops of these the vents and cones and things. We'll have to try to find some video to show you guys next week for that. But it's something that we've been referring to for a while. We're encouraging people to go out and look from those areas, and I know that a lot of our local community here has been enjoying the relative quiet of those areas compared to the more overrun areas, so we've been trying not to give it away too much. But the USGS gave it away with their map earlier today or earlier this week as well. So it seems like the time has come to announce it to everyone. So we'll discuss that here shortly as well. But first, focusing on the best viewpoint at Kanekakoi, here is the last 2 weeks of S1 camera, which gives us a representation of the starting and stopping nature of the eruption over the last 2 weeks. Over the last week, it's only had 1 pause, but the week before it had 4. So it's really start and go, and the last week's been pretty good with viewing because there's been relatively few pauses, but it can be sporadic, and it's hard to tell what you're going to get. But after the pause, there's usually a surge forth, and you see lava shooting out from the side vents or along the back wall over here, or refilling this corner of the pit over here. All of these things that we've been discussing for the past couple of weeks here. So that's most of what you can see. You can also see these ooze out flows in the back part of the crater there, and the overflows over this way from the Kanekakoi side as well. While we're looking at this S1 camera, important to note that this white area down here in the south still got glowing cracks, just like that spot in the west we discussed earlier. And that one puka, the one opening over here, you see is still glowing. I put out lava a few weeks ago, eastbound of this central island. Lots of different things you can see from there. Can't quite see all this area right in here from the overlook, but you probably can see something like this. I would wager something like that. And as a crater floor is rising more and more and more, it's coming more and more into view from more and more areas. So really, these are the glory days of lava viewing as far as how I would describe them. And along those lines, we'll switch into some viewer submissions. This is from Two Pineapples. Mahalo, you guys, Lou and Anna. for submitting this, and I know you guys are live streaming out in Overlook right now. I'm probably not watching this live right now, so we'll check in on you guys here shortly. But a couple clips from these guys. We know that we've been sharing Epic Lava, and these guys are also going out there and streaming, so you can check them out as well. Here they have nice optics zoomed way into that channel coming over that off of that west pond vent that's spilling over into the lava lake. Here's that whole west vent complex to the left side of it, and there's that most active lake. In this particular view, it's filling that little embayment there all the way up, right? There's that wide view, so a little bit of ooze up flow is visible on the far right side of the view there as well. And so good representation there. I mean, there's a lot more caldera that's out of the field of view here, so it's really cool to see these guys be able to set up the streaming equipment there portably at a national park. Okay, so yeah, you can see the various spatter bursts from all those different openings in the West Vent complex. A little bit shaky, but go. I'll advance to this next one here, which is just a slightly more stable view of that spillway from that bubbling West Vent pond spilling over down through here. And then this is the opening right here that's been crusted over. So this is a view from a few days ago. And what I'll do now is I'll just switch over to see if I can get this to play. If these guys are live right now. Live view of the volcano. It looks like it's pretty foggy right now, but you can see kind of crusted over area in between the upper pathway here and here. Right, so we'll keep moving on. So here is the USGS map that we have available since March 4th. That overflight on March 2nd was what allowed them to catch this data. So there's a lot to look at here as far as I'm concerned, and this is one of our data sources that we look at pretty closely. So we have here all the different labels: the eruptive vent, persistent vent, intermittent lake, focused inflows, and island, right? So that's the terminology being used now. The intermittent lake shown in red, the persistent pond in purple, the current vent complex area is this orangish over here, and then all the yellow stuff is the little bit that remains from the last eruption is still sticking up, right? And there are probably some cores in here that are older crust as well, but they're noting the islands especially in particular. That's the orientation of it, and you can kind of see this dashed line is the original extent of the 2021 and 2020 lava. So it's not exactly that same kind of core of the crust, so it seems like it's inwards of that a bit. But that gives you some idea of the growth outwards from that extent. The other thing that I really like to pull out of here whenever it comes out is the statistics, which are always in this little box down here. Sometimes this is all we'll talk about during some updates, but today we'll catch it all up. This is the first map in about a month, a little over a month. And our surface thickness, you can see those stats right there, but I'm going to focus on volume. Our volume is now up to 53.6 million cubic meters, 14.2 billion gallons. So last week it was 45 million. I'm sorry, last month 45 million. We're up to 54. So this thing is still pumping in a lot of extent. 199 acres in total now. The numbers are hard to visualize and hard to remember and keep track of, so I'll come back to our graphs once again. And there's two graphs shown here, two lines. The red line is our current eruption. The blue line is the last eruption at the summit of Kilauea. What we've done is we've reset them both to days into the eruption. So 0 days into the eruption, the last eruption lasted about 5 months. And that ended right here at 41 million cubic meters. And now we're into our, we're past that, almost into our fifth month here. That's more recent eruption. What you can see is that the line in blue began more steeply, but then flattened out sooner and ultimately stopped at a lower value, right? Whereas our eruption began also very quickly, but didn't really flatten out as much. You can see it's not as fast as this rate over here, but going back to about month and a half into the eruption, the rate since then hasn't really changed substantially, really. It's been pretty linear, which is fascinating because that's not what happened the last time. Right, so because of that, we have exceeded the threshold of lava that came out the last time. We're now at 54 compared to 41 from the last eruption. That's 30% more already, right? So we've been, not only has it been going longer, the last few months of it going longer has been at a higher rate, and this is shown by the slope of this line right here. And so that's why we're really adding volume pretty well here. And so this is really interesting and something we'll discuss when we talk about the Volcano Watch and this whole idea of an open system that we've been hitting on for a while here. Okay, so that's the total volume erupted, right? The total amount reported. But we can also look at this as far as intervals between each map. So between the last map and this map, our value has been 2 cubic meters per second, which is average long term, right? Actually the whole eruption is now down to like a 4, but you can see the pattern is pretty similar in both eruptions. Peaked high early. Actually, our eruption ongoing now peaked slightly higher, 10% higher within that first day, but both crashed down very quickly and have been in this lower values for months and months and months and months. However, at no point has our current eruption dropped down below this 2 cubic meters per second volume right here, whereas the last eruption did that about 2 months into it. So really the last 3 months of the 2020 to 21 eruption were at lower rates than we have going on now. So if you're wondering how long this is going on, it looks promising. It's gonna keep going for a while if the last eruption is any relative guide. All right, and so for you guys who don't see the graphs as easily, I thought I'd put this a little bit visually here. And so I've put on the top, this is the beginning of the, this is really squished down. I took the thermal engine, squished it down half the screen, but this is the beginning of the 2020-21 eruption, and down here the 2021 and 22 eruption. So when you play them side by side, you can see a similar progression of a lot of lava covering the crater floor to not a whole lot. And the top one peters out first, whereas the bottom one still going. You can see it's actually flashing a larger radius, a larger area all around. So side by side comparison, top to bottom comparison here of the last eruption and this one. You guys, I prefer to see it visually. Ours is still going longer, putting out more lava so far. Okay, we'll look at some of the signals now. The lava depth gauge has been not updating to the web so frequently in the last week. So since we have seen that close correlation over the last few months, we'll just use the tilt as a proxy here and presume the lava level was probably high and then drop down and probably stay down a little bit longer than the tilt came back up, right in there, comes up, and it's probably somewhere in that range of something like that. So probably similar, if we had to guess, something like that, matching the tilt last week. But the tilt for the last week hasn't changed a whole lot. We're looking at 1.5 to -2. That's 3.5 microradians. Not a huge amount, but enough to note this one larger deflation-inflation cycle that corresponds with the pause. If we look at the last month, you can see that we've actually had relatively few pauses. Maybe one smaller one here, but relatively few pauses in the last month, last week, I should say. Then the week before that, or the week before that, and the week before that, right? So overall, the tilt pattern has been fairly flat, if not slightly going down. But within the last week or so, it seems like it may have turned around, and we had some slighter rises coming up here. And maybe you could say that we're on a general, on average, slightly rising trend, but it's pretty close to flat either way. So the last eruption was able to end while the tilt was rising. So this is just showing that there is not. It doesn't seem like the pressure is building up underground. It's able to release it to its satisfaction so far, at least. Here's our gas values. Similar scatter corresponding to the values of effusion there. Our GPS, it seems like it might have sped up slightly, but it's back to its average, right? So if something happened, it was a temporary adjustment. And interestingly, if we go down to Puo'o, we're seeing some extra scatter there as well, but likely same kind of continuing trend of contraction there. So nothing really different as far as the geophysics are showing. Earthquakes are still down, or actually kind of boring this week. We won't talk about them too much. Values have been fairly constant. It's actually been fairly quiet around the summit. but south flank still continues. Pahala maybe is back to its usual activity. There's our cross section. And you can see most of these earthquakes occurring in Pahala down at these lower depths and not as much here in shallower areas. Okay, last month, scroll through that, but really not a whole lot there. The big earthquakes down in Pahala continue. We've had a 3.6, 3.3, 3.3. These are all those deep earthquakes, but otherwise it's a pretty boring map compared to what we're looking for as far as those changes in the overall long-term patterns. A little bit of action around Mauna Loa, but not enough to really warrant us going to a full update today. Noteworthy that they're still ongoing at low levels. All right, so now we're going to turn to the last couple of things of the volcano watches, and before I get into that, here I think a question just caught my eye, which is why I pause here. So a question here from Kenny. Is the fusion rate technically 0? The lava inflow and drain is net neutral, since lava rises and falls with the ice cycles like the old lake. So that would be the case if the whole baseline wasn't rising, and that's what we're trying to point out with that long time lapse and showing a bulging in the lake and that whole crater floor actually rising. The whole thing is coming up together, and on top of that, there's this little wiggle on top of that thing. So long-term pattern is rising, rising, and rising, and a little bit wiggling, and a little bit wiggling, and a little bit wiggling, filling. The overall pattern is this whole thing is filling more and more and more and more. So when I'm talking about the fusion rate now, the value of 2 cubic meters per second is averaged over since the last map. It's probably about a month, maybe 5 weeks or so. And for the whole eruption, it goes back to September, and that's still putting us at 4 or so eruption there. Having peaked at 127 cubic meters per second, if you're wondering the relative scale there. So, another question from David Joseph. Any estimates on how much lava went into the lake versus the last eruption? I think that's he must have asked that before I showed the graph, since I showed the graph just now. So yeah, we're at 54 versus 41. So mahalo for the question, David. You obviously knew where I was going with that. Led right into that. And what do we think about the magma chamber under the crust? Yeah, I like it. I like the ambiguity of talking about it being called a magma chamber, right? Because it technically is a whole body of lava underground there, and that's by one version of definition. And of course, everyone's taught at a different place in the world by different teachers and slightly different definitions. But that to a lot of people is magma, lava that's underground right there. So it is essentially a very near surface chamber. Yeah.
Yeah, if you were to come up on it right now without knowing the history, you would probably call it a magma chamber, just seeing what it is. But we just saw the whole progress. So it's weird watching in this high-speed geology that is Hawaiian volcanoes.
Yeah. I will probably go crusted lava lake. I mean, I could see magma chamber, but
right.
we don't have to stick to the giant buckets given to us in elementary school either, right? We could refine that a little more. So in that sense, like the whole thing is liquid underneath. Even if you could land down there and walk around, I'd be very hesitant to do that, because any portion of it at any moment could become a giant lake of lava, even if it looks like it's solid on top, right? So yeah, interesting gray area. I like talking about that gray area. So mahalo once again, David. And one last question here, since we're just mentioned Mauna Loa and Loihi. Is Mauna Loa refilling with all the recent earthquakes along with Loihi? Well, Mauna Loa is refilling. That's the long-term pattern of it. That's perhaps the reason why USGS keeps it at alert level orange, watch level orange, despite the fact that there aren't any signs of any increased activity. Nothing's imminent. Nothing's happening very fast or changing very fast for a while now. But it is refilling in the long term. So what I should say on top of that is, just because it refills does not mean it's going to erupt, right? It's been refilling for a long time without erupting, and it can keep doing that as well. So yes, Tanya, refilling, but does not mean anything as far as eruption. For those who are alarmists, there's no reason for alarm from Mauna Loa right now, or Loihi for that matter. Or Pahala, although Pahala is really interesting as far as why all these earthquakes are occurring more so in the last few years here than prior decades. So we'll leave that there. We'll jump into the Volcano Watch and look into today's Volcano Watch to start. This is already posted on HawaiiTracker.com. Magma chamber music can tell a revealing tale. And so they're looking at vibrations of the ground. This is something that's normally in the field of seismology, but where you can start calling it, you can start specializing into different kinds of signals, right? And so these are the resonance signals. And so a normal earthquake that shakes the ground that's solid might last 20 seconds in the range, less than a minute, something like that. But as an example, on the bottom here, from a collapse of a large rock into the Halemaumau lava lake back in 2013, there can be a 20-minute oscillation of the ground as the magma is sloshing back and forth on the ground, and actually causes the ground to oscillate a little bit in response. So the seismometer is feeling that longer frequency swaying. That's what this is measuring here. And so if you can track that and track how that changes over time, how it comes from different places, comparing one situation to another, you can gain some insight in a volcano that way. So I won't read everything here, but I will kind of jump down to the money paragraph here, right? They have some great analogies relating magma or lava to water or syrup, and how those things can vibrate, or water in a glass. But really, the key thing here is that that resonance has helped reveal Kilauea's shallow magma system geometry. For example, suggesting that a conduit connecting its shallow summit magma reservoir with the overlying lava lake into Halemaumau 2008-2018 was more than 50 feet wide. I shouldn't have read the whole sentence, but that's the key thing here. 50 feet wide is what they believe was the size of the opening below the lava lake that lasted 10 years at Halemaumau before. That was the one that was that open system that we saw changed essentially 1-to-1 with changes in the tilt. The lava level will go down and up as well. So that's one part of it. This other sentence doesn't have a number, but I think it's equally important. It's also revealed complex magma dynamics over the past decade, including convective overturns. You can see like it being more frothy or more or less resonant, and melt supply pulses. I like that one there. It's just dropped in there. Melt supply pulses, which inform the restless nature of Kīlauea volcano. So over the past decade, there have been melt supply pulses, and we can essentially see that same pattern now, right? We had the pulse of the first eruption, 2020-21. Melt still coming in, but then it essentially pulsed again to be able to initiate the current eruption, which is still ongoing. Okay. And since Volcano Watch posted last week after I had done my short recording, and Dane did an excellent job discussing everything, of course, all the images. But I did want to touch on that one aspect of the open or closed system. So just to recap it a little bit, here is the plot from 2017-18 of, in green, the tilt at Wekahuna, and in blue, the lava lake level of that very open system. And as Dane mentioned before, the 2022 has a very similar pattern, but with a clear offset between the resumption of inflation and a resumption of lava coming back to the lava lake, right? The inflation's got to resume. It's got to reestablish some level of pressure, meaning there is something blocking the lava coming out during this phase, especially, right? So while the system is behaving much more closely to an open system, it's not a fully open system as indicated by this lag in particular, right? So it's interesting to note that it may be developing into that system, because it's starting to show this pattern much more than it was before November, but it's not doing it 100%. And that's something that they actually discuss here. Interpretation was that there was a fully open connection between the lava lake and shallow summit reservoir in 2008-18. See there. As a result, the lava lake acted like a barometer. They relate that to what's happening recently now. But where is the sentence? It says here. The current lava lake Halemaumau rises and falls together with inflationary-deflationary tilt. This indicates that to some extent there is again an open connection to the shallow Halemaumau magma chamber. However, some of the cycles are larger than others. Yeah, that's another aspect. Some of them are small ones, some are big. Right, there's two different kinds, and there is that delay. Right. So this is an indication that the connection between the surface and the shallow reservoir isn't always open. Right, and so that's another interesting thing there. So that's all I wanted to mention, just because we've been talking about this open system for a while, and it's great to hear USGS put it in writing here. Volcano Watch this week. So all this information is coming from the USGS HVO. Just to remind you guys, they are putting out updates every day in the morning and afternoon. The afternoon one's a short update on the viewing conditions. So, for example, today they put out that because the eruptions remain constant since the morning update, lava will likely be in the surface of the active lava lake this evening. That's what you're looking for in this late update, is this lava will likely be on the surface or it will not be on the surface. So I'll scroll down here, you can see the morning update. One thing I put this in to remind myself, I forgot to mention, the current active lava lake surface on Halemaumau is only now 2.5% of the Halemaumau crater floor. Right, so that area, we're really zoomed in, it's only a very, very small area, 2.5% of that growing area there. So their volume is still set as 45, but as we noted on the map, this is going to be updated to 54 anytime now, since it's already published on the map there. Otherwise, everything is pretty standard. I won't go into the detail there, but you can see previous days. Lava will likely be on the surface this evening. A couple more days. Lava will likely be on the surface this evening. A couple more days. The inflation, so has resumed since the morning. Lava will be on the surface this evening. And then if I go back one more day, just to show you guys what this looks like. Okay, this was back on Sunday. Deflation at the summit was mentioned has led to near pause eruption at the time of this notice. So lava will not be on the surface this evening. That's the difference there. All right, so that's essentially it. We can turn to our thank yous. I'm gonna just play in the background this USGS overflight video from last week. Getting some of the wider views of Mauna Loa in the background, inner pit with a growing lava lake surface in there within the innermost collapse pit and the caldera and all of that as well. So, Dane, I'll stop talking now.
Yeah. All right. Well, I want to thank everybody that tuned in today. We wouldn't be able to do this without viewers like you supporting us. We don't have the advertising budget of a lot of bigger organizations, so we rely on the viewers to help share the message and get the word out that this stream exists and this content is available. So if you like this, subscribing always helps, but apparently one of the bigger things to help the algorithm on YouTube is commenting about the video after the video ends, after the live stream ends. So what was your favorite part of this eruption or the previous eruption? What eruptions stick out in your mind? Is it still 2018? Do want to thank everybody that made monetary donations. We did have one $20 donation from Judy, who says, "Hi guys, appreciate the support, Judy." As always, if you do want to make monetary donations, we also take those on hawaiitracker.com/support. hawaiitracker.com is where we post all of our information that we put on the social media, but it's in a chronological order, so it's easy to go back through. We do want to thank our one longtime supporter, Kaleo's Bar and Grill in Pahoa, as well as in Orchid Land. The Orchid Land location is their new spot. It's really nice. They got indoor, outdoor dining. They got in 2 unique menus so you can get a different experience at each location. The menus are some local twists on some more traditional dishes. They have takeout options, so definitely check out Kaleo's Bar and Grill if you're around Pahoa side of the Big Island. Definitely recommend them, and we appreciate their longtime support. I think with that, we can get into some. We have a longtime returning supporter, Gary Bryan, who says a $35 donation. Says, "Thanks, guys. Appreciate these updates and appreciate the support, Gary." All right. I think we got through a decent amount of these questions. I did have one, though, and I was trying to rough through the calculations in the last 5 minutes, and I couldn't get it to work exactly. So we know that the volume of the shallow magma chamber from previous calculations was roughly 1.5 kilometers cubed, correct?
There's a big range on the estimates of that, but we can go with...
I mean, even if we take a 1 kilometer, as a minimum, 50 foot wide, that's, if we model it as a right cylinder, that is a very tall cylinder in order to get to that volume. That's the part that's it's tripping me up, and I'm sorry to throw this on you right now, but this volcano watch just came out, and just thinking about it, I was trying to figure out how deep that would have to go. that 50-foot wide chamber.
Yeah, so
Right.
I feel like it's so the 50 feet wide. That's
Right.
it's modeled essentially as like a spheroid, right? So it's not 50 feet wide. It's more. I want to say it's like a on a range of half a kilometer sphere, something like that, right?
Right.
Like
That would make more sense.
I'm just pulling from memory now, just rough orders of magnitude, right? Something like a couple hundred yards under the surface is where they thought the top of the chamber might be, kind of thing.
So that's the conduit, the width of the conduit coming from the chamber, that 50 feet up to the surface?
Yes. So between that 200 yards down, 200 meters down, and a surface, the size of the pipe coming up,
Right.
50 feet. So
okay, that makes more sense.
Point being, a 50-foot wide pipe is harder to block, right? With even a deflation, inflation, or circulation and rocks recirculating and lava, whatever else, it's hard to block a 50-foot opening. If we say have like a 5-foot opening now, because we just restarted this whole thing, and 5 feet's plenty because we think that 5 feet might have been the size that fed the whole East Rift eruption of Pu'u'o for the entire time. I mean, more or less, maybe it's 10 or whatever, but even 10 feet. You can block a 10-foot hole more easily than you can a 50-foot hole.
Right.
Very easily. So I think it comes down fundamentally to that. Like there's just like some, whether it's goo or gunk or whatever it is, like it's just the geometry bit's still small enough. It's still evolving to the point where it's having this delay because we're seeing that animation.
Right. Well, it's good to clear that up. And we did see it get clogged once. I mean, 2018, it took a caldera collapse to clog that pipe, or that conduit.
Yeah.
So it's not easy. Not easy. All right. Well, thanks for clearing that up. I wonder if anybody else had that confusion in their head.
I got you
worth
now,
talking about a little bit.
Yeah, 50 feet. Yeah, as the connector from that deeper chamber to the surface, rather than actually. Yeah.
All right. Cool. All right. So we got those done. I think we got through all the questions.
All right.
So, all right. Well, so if that's it, we appreciate everybody that came through. We will be back next week. Sorry about the delay today, a little tech issue. We'll be back at 5 p.m. Hawaii Standard Time on Thursday, as always, unless something happens, and then we will go live with a special broadcast. But as of right now, that doesn't look very likely unless something changes. But I'll pass it back to you, Phil.
All right, Danny. I don't really have anything else to add. So thank you guys for joining us. We'll come back to you guys one more time next week, as usual, as Dane just said. So, on HawaiiTracker.com, he's Dane DuPont. I'm Philip Ong.